This video goes with the diagram from U4Me. This diagram is not drawn to scale by any means. This center section is found in the Atlantic Ocean, and this section on the left is found in the Pacific Ocean near Japan. The area in between is where North America would be found. So clearly it's not drawn to scale. There's a lot more space in between those two areas. It's shown this way so that you can understand how these two areas are connected and the relationship without taking up a lot of paper and a lot of space. Prior to World War II, the sea or the ocean floor was expected to be flat with maybe a couple hills in it. When World War II happened, Harry Hess, who worked for the Navy, was on a ship, and at the time their ships had recently been equipped with sonar. As he was traveling on the ship, he noticed that the sonar readings that were coming back were demonstrating variation in the elevation of the seafloor. By the time he got to the middle of the Atlantic Ocean, he discovered that there was a long mountain range in the middle of the Atlantic. This long mountain range that was on the ocean is called the Mid-Ocean Ridge, or its official name is called the Mid-Atlantic Ridge. The Mid-Ocean Ridge or Mid-Atlantic Ridge is this center section right here that's circled in orange. So it contains multiple areas of elevation. And the way this is created is through seafloor spreading occurs at divergent boundaries that are created by tension. It happens when the boundaries are pulling apart from each other and magma rises. When the magma rises, it cools very quickly. The reason why it cools very quickly is because the bottom of the ocean is very cold and the magma is very hot. When very hot things hit very cold things, a temperature change happens very quickly. So instead of the magma oozing out and rolling down the hill like we see on the continental crust, it literally comes out and hardens almost instantaneously. And this creates these very tall mountains. The rate at which this occurs is very slow. They say that the plates move at about the rate our fingernails grow. So if you think about your fingernails, you don't actually feel your fingernails growing. And if you really think about how quick they don't grow very quickly at all. So we're talking about a very slow pace here. When the seafloor opens and the magma hardens, that area is called the rift. The rift is this black line right here, and that is where the seafloor is actually separating at. The rift area has the youngest rock possible because it's fresh magma that's just hardened. The further you go out from the rift, the age of the rocks gets older. So right here you would have the second youngest rock, and then you would have an older rock, and then this area would be the oldest possible rock. Now, if our seafloor is spreading and the Atlantic Ocean is getting larger, why is the world not getting larger? Why is the entire planet not expanding? Well, that's because when the plates meet another plate, right about this area, it gets pushed down. We call that a subduction zone. The subduction zone is where two plates meet that are of different densities. The more dense plate gets pushed down underneath the less dense plate. This can occur when continental crust and oceanic crust meet, or oceanic and oceanic meet. The reason the more dense plate goes underneath, if you remember back to our density lab, is density is the amount of mass per unit of volume. Mass is the amount of matter. So literally something that's more dense has more matter in that object per unit of volume. So it's harder. So it's a significantly harder rock. And when they're pushing towards each other, they're coming together. That's a convergent boundary, which is created by compression. Because they are of different densities, the one that's more dense is literally just going to try to slide underneath the one that is less dense. Well, this doesn't work very well because we have very rigid material that we're talking about here. We have rocks. So they're not very flexible. Where they meet, it creates a gap, and this gap is called a trench. One of the more famous trenches is called the Marianas Trench. The Marianas Trench is found in the Pacific Ocean near Japan. The Marianas Trench is 6.7 miles deep. And trenches are unique in the fact that they have the oldest rock at the very bottom of them. This is because, if you remember, the rift has the newest rock. And so, therefore, the rock that's the furthest away from the rift, which would be in the trench, is the oldest possible rock. As a plate gets subducted, as it gets pushed down, it has to go somewhere. Well, what layer of the earth is underneath the crust? The mantle is found underneath the crust. When a plate gets pushed down into the mantle, it melts. And when it melts, it turns into magma. As it turns into magma, it is eventually pushed back up onto the earth, either through volcanoes or through the opening of a rift. Now, mentioned before, when two plates collide and the plate is subducted, that means they are of different densities. The two plates of different densities is the continental crust and the oceanic crust. The continental crust is less dense because it is made up of granite. Granite is an intrusive igneous rock that is cooled slowly. Oceanic crust is more dense because it is made up of basalt. Basalt is an extrusive igneous rock that is cooled very quickly. Also, basalt has a lot of iron in it, which causes it to also be more dense. And as mentioned before, due to the different densities, it causes the oceanic crust, which is all of this right here and this, to be subducted or pushed up or pushed underneath the continental crust. And the reason why the oceanic crust here is subducted underneath more oceanic crust is because it can still vary in densities based on the thickness of the layer. So the thicker the layer, the more dense it is as well. And as we mentioned before, the closer to the trench it is, the older the layer is, so probably the thicker it is as well. So if we look at seafloor spreading as a whole, we have a divergent boundary occurring right here where the seafloor is actually opening up, creating mountains. It's creating mountains because lava cools very quickly. And we also have two plates colliding in this area, which is preventing the earth from getting larger. So it's kind of, in a way, maintaining the size of the earth or maintaining equilibrium by spreading in some areas and then compressing in other areas. But due to this motion, it has caused the supercontinent Pangaea to separate, and it will eventually cause all the continents to come back around, the Pacific Ocean to basically not exist anymore, and the Atlantic Ocean to be the largest ocean possible. When Harry Hess discovered that the seafloor was spreading, it was coupled with Alfred Wegener's idea of continental drift and the fact that the continents were separating and moving apart from each other to create our current theory that we know as plate tectonics. I hope this helps. I hope this makes sense. And thank you for listening.